All right, so get this. We're diving into hula-hooping robots today.
Hula-hooping robots.
Yeah, you sent over this article, Hula-Hooping Robots Solve Physics Puzzle. And honestly, I am way more intrigued than I thought I would be.
Yeah.
Like, who knew that those spinning toys had scientific secrets?
Right. It turns out that hula hooping is like a surprisingly complex, like dance between physics and human biomechanics.
Okay.
And researchers are using robots to try and like crack the code.
Robots. Okay, now you've got my attention.
Yeah.
So what is the big deal about robotic hula hoopers?
Well, these robots are helping us understand something called sustained oscillation.
Sustained oscillation.
Which is basically the science behind how things stay in continuous rhythmic motion.
Right.
So think about like a pendulum swinging back and forth.
Got it.
Or in this case, a hula hoop like circling your waist.
Yeah.
These robots are designed by researchers at NYU.
Okay.
They're miniaturized, and they're 3D printed to precisely mimic human movements, which allows scientists to really isolate and study the forces at play.
So they're like little physics experiments, but on legs.
Well, exactly.
Okay, what kind of insights are we talking about here?
Well, one of the key findings is the importance of body shape.
Okay.
Particularly what we think of as the classic hourglass figure.
Yeah.
It turns out that having like a defined waist and hips isn't just like aesthetically pleasing.
Right.
It actually creates a very specific type of force that helps the hoop stay up.
Really?
Yeah. So think of it like this: as the hoop rotates around the waist,
Okay.
the varying distances between the hoop and the body, due to the curves, generate this push and pull effect.
Interesting.
That keeps the hoop from falling down.
Wow.
It's actually quite ingenious from a physics perspective.
I never thought about it like that. I always just assumed it was about momentum and, not messing up the rhythm.
Sure.
So these robots are hula hoopers. They're basically proving that the hourglass figure is scientifically superior.
In a way.
Yes, keeping that hoop spinning.
It really highlights how something as simple as like body shape can significantly impact the physics of motion.
Right.
And what's even more fascinating is that this understanding of sustained oscillation has implications that reach far beyond hula hoops.
Okay, now I'm really curious.
Yeah.
Where else does this hula hoop science come into play?
Well, one area is robotics.
Okay.
Particularly in manufacturing.
Got it.
So by applying the principles of hula hooping, engineers can design robots that are more efficient and precise in their movement.
Oh, interesting.
So imagine like a robot arm on an assembly line that needs to place objects with pinpoint accuracy.
Right.
By understanding how to create and control that same sort of push and pull force that keeps a hula hoop spinning.
Okay.
We can make robots that move with more finesse and stability.
So instead of just like moving in straight lines, these robots can sort of like dance their way through tasks.
Exactly. They can oscillate and adjust their movements in a much more fluid and controlled way.
Okay.
And that level of precision is crucial in a lot of industries, especially when dealing with delicate or complex parts.
This is blowing my mind a bit.
Yeah.
We're talking about robots potentially moving more like humans thanks to hula hooping research.
It sounds crazy, right?
Yeah.
But it speaks to how interconnected science can be.
Right.
Even something as seemingly simple as a hula hoop can unlock these secrets with far-reaching applications.
Yeah, that's amazing.
It is.
Okay, but it's not just about factories, right?
Right.
The article also mentioned robots for search and rescue or even space exploration.
Yeah.
Are we talking about robots hula hooping their way through disaster zones and across Mars?
Oh, not literally hula hooping.
Okay.
But the underlying principles are the same. So think about a robot navigating a collapsed building.
Yeah.
Or like a really rugged alien landscape.
Right.
It needs to be incredibly agile, adaptable, and above all, stable.
And the hula hoop research helps with that.
Exactly. By applying what we've learned about sustained oscillation and that unique push and pull force, we can design robots that can maintain their balance in even the most challenging environments. So imagine a search and rescue robot that can climb over rubble or navigate uneven terrain without toppling over. Or a space exploration rover that can traverse like rocky Martian slopes with greater stability and precision.
That's pretty incredible.
Yeah.
We're essentially taking inspiration from a child's toy.
Right.
To potentially improve robots working in some of the most demanding situations imaginable.
It highlights how nature and even seemingly simple human activities can be a wellspring of inspiration for technological innovation.
That's amazing.
And speaking of inspiration from nature, let's move on to another fascinating concept that you brought up.
Okay.
The idea of robots that can harvest energy from their own movement.
Yeah, that one really caught my eye. Yeah. It's almost like creating perpetual motion, isn't it?
Oh.
Powering a robot just from the act of moving itself?
It's not quite perpetual motion because there are always energy losses due to friction and other factors.
Right.
But the concept is incredibly compelling.
Yeah.
Imagine robots that can operate for extended periods in remote or dangerous environments without needing to be tethered to a power source or constantly recharged.
That would be a game changer, especially for things like deep-sea exploration or long-duration space missions.
Exactly.
How exactly does this energy harvesting work?
So researchers are exploring a number of approaches. Okay. But one promising avenue involves embedding tiny generators, similar to those used in wind turbines, within the robot's joints.
Interesting.
As the robot moves, these generators capture energy from the rotation of its limbs or other moving parts.
So it's like each movement is generating a tiny bit of power that can be stored and used to keep the robot going.
Precisely. And the beauty of this approach is that it utilizes energy that would otherwise be lost as heat or vibration, making the robot more efficient overall.
This is just wow.
Yeah.
It's amazing to think that we might one day have robots exploring the depths of the ocean or the surface of Mars, powered by the very act of their exploration.
Yeah.
And it all stems from understanding the physics of a hula hoop.
It really speaks to the power of scientific curiosity and how even seemingly unrelated fields of study can intersect in unexpected and profound ways.
You know, we've been so focused on robots.
Yeah.
But the article you sent also mentioned harvesting energy from human movement.
Right.
I'm curious to learn more about that.
Sure.
Is it a similar concept to what we've been talking about with the robots?
It is, in the sense that we're looking at capturing energy that would otherwise be wasted.
Okay.
But instead of robots, we're talking about harnessing the energy generated by our own bodies.
So like using the energy from our steps to charge our phones?
Exactly.
That sounds like science fiction.
It might sound futuristic, but it's closer to reality than you might think.
Really?
Scientists are developing devices that can convert the kinetic energy of our movements into usable electricity.
That's wild. But how does it actually work? What kind of technologies are we talking about here?
So there are a couple of main approaches. One utilizes piezoelectric materials.
Piezoelectric materials.
Which generate an electric charge when they're subjected to mechanical stress.
Okay.
So imagine a tiny crystal embedded in your shoe insole. Every time your foot strikes the ground, that crystal is compressed, creating a tiny spark of electricity.
So you're saying our steps could literally generate power?
It is.
That's incredible.
And it's not just limited to walking.
Right.
Researchers are also exploring devices that can capture energy from other movements.
Okay.
Like bending your elbow or knee.
Interesting.
Imagine a device that charges your phone while you're working out at the gym.
That would be amazing. No more worrying about my fitness tracker dying mid-workout.
Exactly.
But what about more complex applications like those medical implants you mentioned earlier?
That's where it gets really exciting.
Okay.
Think about pacemakers or insulin pumps.
Yeah.
These devices currently rely on batteries that need to be surgically replaced every few years.
Right.
What if we could power them using the body's own motion?
Wow.
Eliminating the need for those invasive procedures.
That would be life-changing for so many people.
It would.
It sounds like this technology has the potential to revolutionize everything.
It really does.
From consumer electronics to healthcare. But are there any challenges to overcome before we see it widely adopted?
Of course. One of the biggest hurdles is efficiency.
Okay.
The amount of energy we generate from our movements is relatively small.
Right.
So we need to develop highly efficient systems to capture and convert it into usable power.
So making these systems more efficient is key. What else?
Miniaturization is another challenge.
Okay.
Nobody wants to walk around with bulky, uncomfortable devices strapped to their bodies. We need to find ways to make these energy harvesting systems smaller, lighter, and more seamlessly integrated into our clothing or even implanted within our bodies.
I imagine there are also safety considerations, especially when it comes to things like medical implants.
Absolutely. Any device implanted in the body needs to be rigorously tested to ensure its safety and reliability.
Of course.
But despite these challenges, the potential benefits are enormous.
Yeah.
Just imagine a world where Our everyday movements can power our devices, reduce our reliance on batteries, and even improve our health.
It's mind-blowing to think that something as basic as human movement could be the key to powering our future.
It really does challenge our assumptions about where energy comes from and how we can harness it.
Yeah.
For a long time, we've relied on these external sources like fossil fuels or large-scale power grids.
Right.
But what if we could tap into the energy that we generate just every day by living our lives?
It almost feels like we're coming full circle. We started with these robots mimicking human movement to understand physics. And now we're talking about using human movement itself as a potential energy source.
Exactly. It highlights the interconnectedness of everything.
Yeah.
And how nature can be such an incredible teacher.
Right.
But let's not get ahead of ourselves. You're right. This technology is still in its early stages. There are significant challenges to overcome before we see it widely adopted.
What are some of the biggest hurdles that researchers are facing?
Well, efficiency is a big one.
Okay.
Right now, the amount of energy we can harvest from our movements is relatively small.
Yeah.
So we need to develop systems that can capture and convert that energy with much greater efficiency.
Right.
Think of it like this. You wouldn't want to have to walk a marathon just to charge your phone, right?
Definitely not. So making these systems more efficient is key. What else?
Miniaturization is another challenge.
Yeah.
Nobody wants to walk around with bulky, uncomfortable devices strapped to their bodies.
Right.
We need to find ways to make these energy harvesting systems smaller, lighter, and more seamlessly integrated into our clothing or even implanted within our bodies.
That makes sense, especially for medical applications.
Right.
You'd want something discreet and comfortable.
Absolutely. And of course, safety is paramount.
Yeah.
Especially when you're talking about devices that are implanted or worn directly on the skin.
Right.
We need to ensure that these systems are biocompatible, don't pose any health risks, and can function reliably over long periods.
It sounds like there's still a lot of work to be done.
There is.
But the potential payoff is huge.
Right.
Imagine a world where our footsteps power our cities.
Yeah.
Our heartbeats charge our medical devices.
Right.
And our everyday movements contribute to a more sustainable future.
It's a vision worth striving for.
Yeah.
And who knows, maybe someday those hula-hooping robots will be powered by the very people watching them spin.
That's a fantastic image.
It is.
So we've gone from tiny robots revealing the secrets of hula-hooping to a future powered by human movement. This deep dive has been a wild ride.
It's amazing how a seemingly simple topic can lead to such profound insights and possibilities.
It is.
And it really underscores the importance of curiosity, scientific exploration, and thinking outside the box.
Absolutely. This whole conversation has made me look at the world a bit differently. Who knew there was so much potential hidden in plain sight?
Exactly. And that's the beauty of science. There's always something new to discover.
Yeah.
And often those discoveries come from the most unexpected places.
Well said. And that brings us to the end of our deep dive. But before we go, I want to leave our listeners with a little challenge.
Right.
Take a look around your own life. What everyday activities, objects, or phenomena pique your curiosity? What hidden scientific secrets might they hold? You never know. Your next question could spark a breakthrough that changes the world. That's it for us today. Until next time, keep exploring.